guys, welcome back. Today I'm going to talk about the open-close principle, which is the second S.O.L.I.D principle. We will first try to understand this principle and then apply it in real code. I will show you some code that violates this principle, and then we will fix it using two of the most frequently used design patterns, strategy and factory. We have a lot to cover today, so let's get started. Let's first look at its definition. The open-close principle says that software entities should be open for extension, but closed for modification. Now at first this might seem contradictory. How can an entity be open and closed at the same time? But essentially what this principle is trying to enforce is that once you have created and tested a software entity, you shouldn't touch it. First, let's look at some examples of objects that follow this principle in real life. If you look at a computer motherboard, it allows you to extend memory or graphics card without modifying the motherboard itself. Similarly, when we wanted to play a different game on a classic Sega console, we only had to swap the cartridge. Remember that when we modify code, we can potentially introduce new bugs, and we never want to accidentally create bugs in a code that is working correctly. So if we shouldn't modify our code, then how can we extend it for new functionality? The answer is with polymorphism and inheritance. Let's look at a scenario. We need to calculate the discount for different types of users. All our registered users are by default considered bronze users, and they will get 2% discount on all their orders. Once they have spent $200, they are upgraded to silver rank, and then they will get a 3% discount on all the orders. When they have spent $1,000, they are upgraded to gold members, and now they can enjoy 5% discount on all their orders. If we have to implement these rules in code, we will need to create a conditional block that will first check the membership status of the members, and depending on their status, calculate the discount for them. Now in the future, if we have to introduce platinum users, we will need to come and modify this code. We will need to add another conditional statement and then add code to calculate the discount for platinum members. This means we are violating the OCP because we will need to modify this code in order to extend it. Another important thing to notice here is that this code is also violating the single responsibility principle, because it is responsible for deciding which discount method should be used and then also contains the code for calculating discounts. Most often, if your code violates one S.O.L.I.D principle, then it will be violating another one as well. If you haven't already, check out my video on single responsibility principle to understand it in more detail. Okay, now let's look at an example of the open and close principle in code. I'm going to create a simple application that calculates shipping charges for various countries. Our requirements are very simple. We offer flat shipping to different countries. We will charge $5 flat shipping to any order in USA and $10 flat shipping to any order in Canada. I have created an empty console application in Visual Studio. Let's create an order info class in our project. This class will contain summary of the order. Now I'm going to add a subtotal property to my class. In real code, we will never do this because the subtotal should be calculated by adding up prices of the products. But here, to keep it simple, I'm just creating one property. Now I will add one property for the country where we are supposed to ship the order and one for the shipping charges. Let's add the main class that will be responsible for calculating the shipping charges. I will call it shipping calculator. Now let's add a method called calculate shipment to this class, and we will pass the order info object that we created earlier as a parameter to this method. Inside this method, I'm going to add a switch statement and check the country that we need to ship to. If the country is USA, then we will create a separate method for calculating the shipment to USA. And if the country is Canada, then we will have a separate method for calculating its shipment. Now my code won't compile at the moment, So I will go ahead and add the implementation of these two methods. And like I mentioned, for USA, our shipping charges will be $5, and for Canada, they will be $10. Now notice how in my code, I have to check for each country first. And tomorrow, if I want to add another country, then I will need to modify this switch statement. Now my shipping calculator class is not only responsible for deciding what shipping charges should be applied depending on the destination country, but also contains the logic to calculate these charges. In the future, if we need to ship our orders to different countries, I will need to change this class. Right now, this code is violating the single responsibility principle as well as the open-close principle. Now let us have a look at the strategy and factory design patterns that will assist in solving these issues. Strategy design pattern is a behavioral design pattern. Its intent is to create interchangeable algorithms that can vary at runtime. First, we create an abstraction interface of the algorithm or strategy that we want to use. Then we create separate classes for various strategies that implement this interface. In our example, we are calculating shipping charges, so I can create an interface called iShipmentCalculator. I will have only one method, calculateShipment, that represents my strategy or algorithm that will vary. This interface will be abstraction for my strategies. Next, since we have only two strategies at the moment to calculate shipment, I will create two classes, US Shipment Calculator and Canada Shipment Calculator. Both of these classes will implement the iShipmentCalculator interface, but their implementation logic will be different, just like our current code. The shipping charges in US Shipment Calculator class will be $5, and the shipping charges in Canada Shipment Calculator will be $10. Once we have extracted our shipment calculator logic in separate classes, it is very easy to extend our code without modifying the existing code. All we need to do is to create a new class that implements the same iShipmentCalculator interface. Now we have solved one problem. We can extend our code and create new strategies without touching the existing code. But there is one problem still left. How will we decide which strategy will execute when? This is where the factory design pattern comes into play. Factory design pattern is a creational pattern that defines an interface for creating different objects. In our example, we need to create different strategies for calculating shipment charges. How do we decide which strategy to create? Well, we look at the shipping country and create our strategy accordingly. This will be the responsibility of our factory. I will create a shipment calculator factory class with one method, createShipmentCalculator in it. In this method, I will add a switch statement that decides which strategy to create depending on the country. The important thing to note here is that this method will return an instance of iShipmentCalculator interface, which is our abstraction. So let's refactor our code and see how we can apply these patterns. I am back in Visual Studio where we left off. Let's first create the interface for our strategy. I will call it iShipmentCalculator. This interface will have only one method, calculateShipment, that will be implemented by all of our strategies. Now let's create the first strategy class, US Shipment Calculator. This class will implement our strategy interface, and for the US, our shipping charges were $5, so let me go ahead and add them. Now I will create the second strategy class. Let's call it Canada Shipment Calculator. This class will also implement our strategy interface and provide its own implementation. The shipment charges for Canada are $10. Let's implement that. Now imagine if I need to add a third strategy for a different country. I can easily do that by creating another class and implementing my interface. Now let's refactor these classes into separate files. Now our strategies are ready. Let's change the calculateShipment class and start using them. First, I will create an instance of our iShipmentCalculator interface. Then let's initialize the correct strategy according to the shipping country. Once we initialize the correct strategy, we can simply call the calculate shipment method to execute it. Now at this point, it might seem that I have added no value to the code. Instead of using methods that I created earlier, now I am just using abstraction to calculate shipment. My switch statement is also still there in code. But once I create the factory, these code smells will be resolved. So let's go ahead and create our shipment calculator factory. This factory will be responsible for creating our strategies. I'm going to create one method in it that will return the correct strategy according to the shipment country. Now this factory's sole responsibility is to create the correct strategy, and the only reason it will ever change is if we need to create a new strategy in the future. Now let's use this factory in our shipment calculator class. I will remove the switch statement since this class will no longer be responsible for creating strategies, and let's use our factory. I will pass the country to our factory class and it will handle the rest and create and return the right strategy instances for us. One important thing to note here is that I'm using the new keyword to instantiate this factory. In the production code, I will be using dependency injection and inject this factory, but for the purposes of this demo, we will keep it simple and just create an instance ourselves. Now let's look at our code. My shipment calculator class is simply requesting the factory class to create the right strategy and then executing it. And all our logic is encapsulated in the strategy classes and the factory itself. Now since I don't need the original methods that I created to calculate shipment, let me delete them. And this is the final version of our code after refactoring. In the future, if I have to create a new strategy, I will simply create a new class and extend my current system. Now one question that you might have in your mind is that in that case, the switch statement inside our factory class will still need to be modified. And that's true, because we will be extending it and its sole purpose is creating strategies, so we will not be violating the single responsibility principle as well. That's it for today guys. If you liked this video, please hit the like button. Do subscribe to my channel for more interesting stuff. I will see you all in the next video. Till then, take care and happy coding.